Hello everyone, my name is Hojjat and I am the founder and CEO at DeltaStream. Thanks for attending the talk. So I will be talking about the role-based access control in a streaming world. I guess most of you already heard about role-based access control in normal world or old-fashioned world, data at rest world. So here it's more like an opinionated approach. I'll give you a little bit intro on like what's state of the world at the moment for role-based access control in similar or in streaming systems, and what we propose as another way of doing role-based access control for your real-time data compared to your static files or tables. Well, I guess I don't need to talk about streaming and real-time data at this conference, but as a mandatory introduction, as you know, we are having streaming data everywhere, from IoT and InfoSec to ML and AI and mobile and gaming, all of these things, plus many, many more applications. And we are seeing the growth in the volume of data and amount of applications that people are building on real-time data. So it's very important to kind of like not only have applications and use cases on those, but also have them secure and make sure that only people who are authorized are accessing that data. So as a main or building block of a lot of streaming systems, you have a streaming storage. You can think about streaming storage as systems like Apache Kafka, Kinesis, or Apache Pulsar, and there are a few other systems that you can consider them as a streaming storage. I call them streaming storage because they usually don't do any processing. Data comes in bytes and data goes out in bytes, and the whole thing here is that compared to storage services in the batch world, you have a stream of data. Data continuously comes and data continuously can go out of the system. These are backbones of streaming data. Any place that you have streaming data, one way or another, you have Kafka or Kinesis or any of these systems. And there are two important capability or characteristics of these systems. The first one is that they decouple producers of information from the consumers of information. This decoupling gives you a lot of flexibility on building applications without worrying about like where the data comes from or where the data goes from. In this case, for instance, if you have an application that's producing data to your streaming storage, you don't care about who's going to use this data. And anyone who wants to use this data just taps to that stream and continuously consumes it. And it's scalable. You can have 5, 10, and as many consumers as you want without having to change anything in your producer. Another important characteristic of these systems is their low latency. You can do the same thing with a file system in the batch world, but you wouldn't have the sub-second latency that these systems are providing for you. So with these two characteristics, they kind of like build the backbone for your streaming data. And once you have your data flowing through these systems like Kafka, you will be able to build real-time applications and get real-time insight from this data. But while a lot of talks and systems have been focused on processing these data, not that much work or effort have been done for simplifying access and control of who can get what and securing this data. So in this talk, I'm going to give a little bit of information about what's going on right now in a couple of these systems, a couple of examples, and what are the other options that we can consider to be able to secure this data effectively and in an easy way. So what do we mean by access control? Very easy. Who can access what and what operations they can perform on this data. Many of the systems, especially Kafka, they already have ACLs or access control list. This type of access control is easy for smaller systems, but the minute that you scale out, it becomes very difficult to keep track of things and control things because you're dealing with every user. You have to work in a user level. And if you have thousands of users, it's not going to be easy, or hundreds of users. It's not going to be easy to track things. So the solution for that is to use role-based access control. So you can actually have abstractions called roles and use them to control who can access what. And then you can assign these roles for specific users and set of users. So the main concepts in role-based access control is that privileges, the operations that you can do on your data, the roles, who can have these privileges to access and perform these changes on data, and of course resources, what the data is or what the resource that you want to authorize people to access and perform operations on it. In general, your privileges determine which role can access and perform what operation on a given resources. And with this principle, you will be able to control access to your data. And in this case, we are going to focus on the real-time data. The important thing is that the same concerns, you have it in the batch role, and there are solutions for that we are going to discuss about it too. So let's use our first example, Confluent Cloud. It's a very popular streaming storage service, if you will, Kafka. It's the main part of Confluent Cloud. And of course, you need to control who can access to your data. In Confluent Cloud, they provide role-based access control. Let's see how it works. So you can control different resources in Confluent Cloud. These are the set of resources that you can control: organizations, environments, clusters, granular Kafka resources like topic, consumer groups, and of course other services like schema registry and KCQ. So these are resources that you want to be able to control access to. And Confluent Cloud has 13 available roles predefined for you. So once you have those roles and you have those resources, you can assign these roles to users, and based on the role that they have assigned to, they will be able to access to the data that you have. So each role also have a view scope and an admin scope. And as the name suggests, view scope, you can just see things. Admin, you can make changes to. So yeah, this is an example of how things are in Confluent Cloud. So once you have roles and you have resources, you will be able to bind these roles to resources, bind these roles to users, and also bind permissions to your resources. So permissions for principals. Principals are your users. So you will be able to say that a specific user has this role, and that user will be able to do all of the things that are assigned or privileges that role has for you. And from the resource point of view, you can say that which role can access to the given resource. For instance, if you are a Kafka cluster, you can say that only these roles have access to this Kafka cluster, so forth. So you have two ways of looking at this role binding here. And the way that you would actually do these operations is using Confluent provided language, if you will, or scripting language. As you see, you can do these things through Confluent CLI or through the Confluent API, Cloud API that you have. This is a very simple one that here, for instance, you are binding a role to the given principal. The user is the principal, and the role is one of those 13 roles that I mentioned earlier. This one is Cloud Cluster Admin, and for a given environment and for the given cluster. Once you run this, the environment, cloud environment is going to enforce this from that point forward. Another example, as you see, is that you are binding for this user the resource owner. So you're making that role resource owner for the given resource, here, as you see. So the important thing, as you see here, is that you have to learn the statements and commands that Confluent created for this for you. So it's an extra step for you to be able to use the systems. So first and foremost, as I mentioned, for the Confluent Cloud, you have to use console, CLI, or API to be able to apply these changes. You need to know Confluent commands. Those are custom commands that Confluent Cloud supports. And also, you have limited number of roles, 13 of them. Let's look at another example and see how AWS MSK is dealing with role-based access control. So in the case of AWS, as many other services that they have, it is based on Identity and Access Management, or IAM service that they have. So all of the access, you can control them through the IAM service. So in IAM service, you will have authorization policies. In these authorization policies, you will define which actions to allow or deny for a given for a given resource for a given role. And there are a list of available actions that you can have. Again, these are the things that you are limited to when you are dealing with the AWS MSK. You have Kafka cluster connect, Kafka cluster describe cluster, and so forth. Bunch of these actions that you have. And some of these actions also depend on the other ones. You need to keep track of them because, for instance, if you want to change anything in a cluster, you have to have connect access level for that cluster and so forth. There are 4 types of resources that you can control access to, and these are cluster, topic, group, and transaction ID for every Kafka cluster that you have. This is an example for AWS MSK access control. You have to build a request like this, and as I mentioned, submit it through the AWS AIM service. You specify what actions you're going to have, you're going to permit for this user, and what resources. And once you send this, they're going to be applied, and from that point, they're going to be enforced. So these are two very commonly used services that provide role-based access control, but each of them, as you see, they have their own custom way of doing this. So if you want to learn any of these things, you have to go and read the documentation. Practically, if you don't have experience in it, you're learning a new system. As I said, it's using AWS IAM, and requests are going to go through the AWS IAM requests. And this can be used through AWS Management Console or the API or AWS CLI. So far, that's the state of the art for the two of the popular services that we see for streaming world. So the question is there an easier way to do access control, or role-based access control, more specifically, for streaming data? And that's the main subject of this talk. And I hopefully will be able to convince you there is an easier way to do that. So what I am suggesting is that this is not a new problem. And we have been doing the same thing in the batch world, especially in the relational world. And if you look at the relational world, it's the thing that it has been around. We have had role-based access control. It is the most familiar systems and data at rest, if you look at databases and relational databases specifically. They're widely being used, and there's a large user space on it. And from open source relational database like Postgres to large as service data warehouses, all of them are using relational model to be able to access process data and also control access to that data. And the question is, why not use the same model that is working perfectly there? Maybe not 100% perfectly, but has been working there. People are happy with it to a very good extent. And why not bring that to the streaming world too? Why not use it in real-time data and not have people to go and learn custom ways of doing role-based access control? So what we are proposing is that let's have a relational model on top of your streaming storage. By streaming storage, we see like Kafka or Kinesis or combination of these, just any of these streaming storage, and not just one, a set of those. Let's have a relational model on top of that. And similar to the way that you would have a relational model on top of your files in S3, for instance, or in the data at rest side, why not have the same model in the streaming world? And once we have this relational model, we can process data with the same familiar ways that you would do in the batch world. You would organize your data with the same way that you would do it in that world. And of course, you can secure it and have role-based access control enforced in this way. And this would significantly simplify the way that you deal with data for processing and organizing your data and also securing data. And if you look at the process side, there has been a lot of effort already. Like if you look at the SQL systems on the streaming side, KSQL, Flink SQL, Spark SQL, a lot of these systems, they bring that familiarity of SQL for processing streaming data, but most of them just stop in that processing part. They don't go beyond that processing for helping you to organize your data and also secure your data the same way that you would do in the batch world. So let's use an example. Let's say I have two Kafka clusters. One of them is in Confluent Cloud, and another one is in MSK in AWS. And I have two topics. There's the orders topic, and there's the customers topic, each of them in different clusters. And I have that relational model on top of these streaming storage services. So we are going to use this as a running example for the rest of the talk. So the first step is that, again, we are going to, if you remember, I had process, organize, and secure, three main pillars of this new relational model on top of your streaming world. So let's start with the organize. Why not organize our streams and streaming data the same way that you would organize your tables in the normal databases? So for that, in the batch world, you had relations. In the streaming world, depending on what type of data you're dealing with, you can have streams, changelog, materialized views, and tables. And the reason I have like streams and changelog depends on how you interpret your streams. Some of them are append only, some of them are changelog or upsert. So based on that semantic, you can also include those semantics in the declaration of your relations. Once you have your relations, similar to the way that once you have your tables and databases, you can build schemas and databases on top of those. Here also, you can also enforce a structure or hierarchy on your streaming data. You will have schemas that are logical grouping of these relations. And on top of that, you will have databases that are logical grouping of your schemas. So you have a nice hierarchy. Unlike all of the existing streaming storage services, think about Kafka, think about Kinesis, you have a flat space. It's not easy to organize or group these things. Now with this hierarchical model, you're a familiar way. It's not like a strange thing. You have been doing these in Snowflake or Postgres anyway. Why not use it in the streaming world too? And now, once you have this, it's going to help you to organize and also secure this data much easier compared to not having this structure on it. So in our example, imagine we had, if you remember, we had the orders stream in Confluent Cloud Kafka, and we had the customers in MSK. These two, you build two relations. One of them is a stream, one of them is changelog, exactly the way that you would build a table from a Parquet file, for instance, in the batch world. You can put them in a schema and inside the database. So easily you can have this hierarchy enforced on your data. Note that we are now in the relational layer. So practically, once you have this relational layer, user is not going to be able to access the topics directly. They're going to interact with the relational layer. Same way that, for instance, when you're using a database, the assumption is that user doesn't go to file system and changes the database files. They are just interacting through the database layer for you. So let's say now that we have those streams declared, we can also run queries on top of that. This is similar to the way that we are running streaming queries in any system. We have also the same way of running these streaming queries. You can join, aggregate, and create new stream from this. And in this case, let's say we want to join these two and create enriched orders by including customer information for every order. And let's say in this case, we want to have the result of this query be written in a topic in the Confluent Cloud cluster that we have. So you can easily say which cloud, which Kafka cluster, and so forth you want to store your results. Once you have that, and let's say you have another query that creates a materialized view and continuously keeps that materialized view up to date with sub-second latency, easily you can see that you can, similar to the way that you would build new tables, and those tables are going to be in another schema and database, you can put them here. The other option would be create another database and put these in another database. And once you have this, again, you have this hierarchy. This hierarchy is going to help you to give access to other folks to be able to use this data. So now we have that hierarchy. Let's see how we can provide the role-based access control for you. So the key concepts that we are going to have, it's again very similar to the key concepts that you have, let's say, in Postgres or Snowflake or any other relational system that people are familiar with. We are going to have users that represents the authorized or authenticated entities in our service. We are going to have objects, or we can call them also securable objects, that you will be able to control access to them. So these objects are normal database objects that you have, databases, schemas, streams, and materialized views, all of these, similar to the way that you would have these objects in, let's say, Postgres. Here also you have those objects available. And once you have those objects, you have privileges. Again, not a new concept. You had all of these things in Postgres, for instance. Same concept here is defined as a level of access for each of these objects. What operations can be done. And finally, you will have roles, the same way that you have these roles in the traditional databases. So in the case of role, it's an entity that you can give privileges to access the resources or objects that you have. Now that you have all of those concepts, you had these concepts in other systems too, to some extent. Not exactly like this, but to some extent. But the important thing is that how you actually assign these roles, these privileges to the roles, to the resources. And again, the point is that what's the point of reinventing the wheel? People have been doing this in the relational databases. Why not use the same thing? Use the same syntax that you have. You can create, drop, alter different roles, users, privileges. Once you have these created, you will be able to use grant and revoke statements that you are familiar in normal databases. You have the same statement in Postgres or Snowflake or other services. Why not use the same thing? So again, I'm saying that reusing those concepts from the batch world and the streaming world makes it much easier for folks to just feel home and be able to secure their data in the streaming world too. These are a couple of examples that I have here for you. So let's say you remember we create that enriched orders stream, and we want to create a new role and give access to this new streams and materialized view that we just created in the previous example. Easily, this is exactly, you can run the same statement in Postgres to give access to a table or a materialized view in Postgres. Exact same thing. You don't need to learn anything new. You can create the role, grant the role, bind the role to the user one, and the grant select action, select privilege on that role, on that resource to the given role. So once you have that, user one, when they go and list, for instance, the relations, they only are going to see the ones that they have access to. They're not going to see the order or customer one. Exactly the things that you provide access. Again, nothing new. Pretty much you have all of these things in the normal databases or traditional databases. You're just saying that why not use the same thing in the streaming world and make it easy for people to just not have to go and learn something new. You're already having these things anyway, and we can easily enforce this. Another example, imagine, for instance, you remember we created a database. In the previous example, I was giving more granular access, for instance, for a stream or for a materialized view. Here, I want to give access to whole database, all of the schemas and all of the relations in those schemas. Very easily, again, you create a new role, you grant you bind this role to the user, and you give usage on database to this role. Again, these are exactly the same statements that you would use in Postgres, nothing different. But here you're enforcing access control and enabling sharing of real-time data or streaming data, going beyond your specific team. You can see the value that you can easily share your data with other teams or with other folks, but share exactly the thing that you want to share. Nothing more, nothing less. So the model that we just talked about, it can easily work on across the streaming stores. Imagine as you saw, I had multiple Kafka clusters. It can work on multiple Kafka clusters, combination of Kafka, Kinesis, or anything, because we are technically abstracting that storage layer for you. That means that once you are in the relational layer, you don't care, for instance, there's a Kafka topic in Confluent Cloud or Kafka topic in MSK. From your point of view, this is in a stream, and you can give access to the stream to any role that you want or revoke access to any role you want. Everything is familiar, so you don't have to learn something new. If you know SQL, if you work with SQL services like systems like Postgres before, you're going to feel at home. So no need for learning something new, no need to kind of figuring out how this thing works in this environment compared to other environment and so forth. You learn once, and you can apply that knowledge to all of this streaming data that you have. That hierarchical namespacing I mentioned, again, nothing new. We have been doing this for relational systems all the time. But here, it gives a lot of power for us to use all of the things that we are used to and we have been doing in the batch world for the streaming world too. So organizing things and being able to give access to group of things. So again, here, if you look at a system like Kafka, you have a flat namespace. It is really difficult to kind of come up with a good way of access control. For instance, in case of ACLs, you come up with prefixing topic names and trying to, for instance, say that all of the topics with this prefix can be accessed by this principal and so forth. Here, it's much more natural. You just organize them in different databases and just grant access to one database or revoke access from another database. You don't have to go through that prefixing business that we have. And the reason for that prefixing is that because in Kafka you have flat namespace. Think about it as a file system with no folders, no hierarchy. Everything is flat. So it's very difficult to do those things there. But once you have the hierarchical namespace in here, it's much, much easier to kind of organize your streaming data. And finally, it gives you a unified view over all of your streams. As I mentioned, this sits on top of all of your streaming stores. If you have multiple Kafka clusters, if you have combination of Kafka, Kinesis, and other systems, once you have this relational layer on top of it, you're just going to see streams, change logs, materialized views, tables, and those kind of things. You don't think about oh, this stream is backed by, the data for this stream is backed by a topic in this Kafka cluster 1 or Kafka cluster 2. That makes it much easier to be able to write queries that can aggregate data from different sources and write to other sources. And finally, same as normal databases. There's no limitations. You can define new roles, custom roles, and add as many roles as you want, and bind them to as many users as you want, and also give access to as many resources as you want for a given role and so forth. And finally, actually, we have built this system. So if you go to this address, we can try it out yourself. That DeltaStream is a service that sits on top of your streaming stores and provides processing, securing, and organizing your streaming data. With that, that was the last slide for me, and I guess I'm open for questions. Thank you very much. Any questions?
What system do you support in addition to Confluent Cloud and MSK?
You can consider, for instance, Kinesis is pretty much similar to MSK, not like exactly, but again, uses AIM, for instance, for role-based access control. The main point that I wanted to make is that there are existing solutions for this, but they are like custom for a given system, and you have to go and learn, read the documentation. Here, we are trying to bring the things that people already are familiar with and apply that concept to the streaming world.
Hi. So to leverage these table abstractions, does the compute have to be within DeltaStream, or can external compute, like your own Flink app or Spark streaming job, can they leverage those same table abstractions?
Compute is in DeltaStream, but you have the option of, if you need the data to be computed by other tools, you can move it to another, let's say, Kafka cluster that you build, and then take it from there. But any access that you have for the existing data, you go through the DeltaStream. And under the hood, actually, we are using Apache Flink as our processing engine. So technically, everything that you can do with Flink, you should be able to do here too. There's another question there.
So you were saying that this is essentially to limit access to a Kafka cluster topic, right? So what is the real use case for it, and why do people do it?
I would say the same use case that you see in the batch world. Imagine you have, let's say, Presto on top of S3. Okay. You always can go to S3 and use S3 directly or delete files and those kind of things, right? But if you're providing it as a service internally, you can force everyone to go through this service and not give any access to the underlying storage. So we are kind of like following the same model. We're saying that, hey, this worked already in the batch world. People have been using these models in the batch world. Why not have it in the streaming world too, and not have to reinvent the wheel?
I see. So what are we really controlling over here? Like, is it when we are processing the data that some of them do not get access to it, or when we are storing the processed data? What are we actually controlling access to?
The processing is type of access, right? Any access that you want to read the data, you want to check the content of a topic, for instance. You don't want to access the topic directly. You want users to go through the system. So once they go through the system, the access is going to be enforced, like access control is going to be enforced. So processing is one way of accessing that data, that once it goes through the DeltaStream, for instance, it will be controlled, and if there's a permission and the privilege, then it can go through, otherwise it's going to be denied.
I see. So you're essentially, like when you're processing the data, you're storing somewhere and you're controlling access over that stored data.
Yes.
I see. Yes.
So
okay.
The idea is that for my users, I don't have to give them access to the store. I can have them to go through this control layer that I can control who can access what, instead of them directly going to, let's say, Kafka cluster or file system or anything like that.
I see. And how do they actually access the data that you stored that's processed? Like, can you give me like a real-world example for it?
As I said, you can try it out here, but you define a stream, for instance, the same way that if you're familiar with Flink, you define a table on top of a topic, or in KSQL, you define a stream on top of a Kafka topic. Once you define that using a DDL statement, you will be able to query it, read from one topic, write to another topic, or build a pipeline, materialize the results, and all of those things.
So a way to look at this would be that let's say you had Postgres, right? In Postgres, all of your data is actually stored on disk as files, right? So the Kafka ACL is like the read, write, execute permissions that you would have on the file, right? But when you're within Postgres, when you're actually running queries or you're trying to describe the schema or the table or something, that is going through the Postgres access control layer. That is the equivalent of our RBAC. So
it's a very good analogy, yes.
Yeah.
In Postgres, you have files. You can go delete the files if you have permissions to the disk system. But in practice, you want to have all of the access go through Postgres. In this case also, you want all the access go through this system, and you wouldn't give access to your Kafka cluster for all of the users that are going to be intended to use this data.
And access control is always built layers, right? So you want to have multiple layers of access control. So you can have the layer of access control at the Kafka level where you have ACLs, and then you can also have a layer on top which is doing RBAC. So the data is stored in Kafka or in Kinesis, right? Other than materialized views, that's different. But if you're talking about streaming data, that is kept in Kafka or Kinesis.
Yeah. Those are the storage layers that, as I mentioned in the first slide, we call them streaming storage services. Any other questions? There's one here.
Can we integrate this with the Confluent Cloud?
Yes, it is agnostic for the storage service. So if you have Confluent Cloud, you will be able to, Kafka from Confluent Cloud, you will be able to have that as another store in the system.
Okay, thank you.
Hi.
Hi.
So I'm wondering, to enable RBAC, right, for schemas, us from Confluent use schema registry with RBAC. What is the equivalent of the same?
Oh, we have catalogs similar to Postgres.
MDS.
We have internal catalog. The same way that, for instance, in Snowflake or Postgres, you have the schemas for your tables. We have the same things.
The
there.
metadata service would...
So schema registry is in the storage layer for us. So again, you wouldn't access it directly. You would access through our service, for instance. Thank you very much.